All right, welcome back. We are COMP1115. That's Game Programming 1 in the fall 2025 semester at Georgian, and it's week 2, part 1 of our broadcast and recording together. And I want to talk about last week a bit. We did a bit of a course overview and some basics, very basic things. And this week we're going to do more. We're going to, again, continue to build on your foundations. So again, we did things like tool setup last week. We talked about Git and GitHub. We did a bit of a tour of Visual Studio. We did an intro to variables, strings. And I also had some stuff in there about pseudocode and flowchart basics that I put in there for you to read, but we didn't have a chance to really go over that. This week, variables and data types is what we're going to be touching. Arithmetic operations, math, basically, some good documentation, and Git workflow. And I want you guys to get into that whole add, commit, and push stuff that we're going to do with Git. So again, ICE 2 slated to be due tonight at midnight. And what I'd like you to try and do is work with me during class so that you don't have any homework, so you can get it all done by today. I know that you have a video to record and Git and all that stuff to submit. Again, all that's supposed to be on Blackboard. So if you have a question around that, or if you didn't have a chance to submit, I haven't had a chance to mark it yet, only because lots of stuff going on in my life this week. So it's been a bit disruptive. Plus, you guys were late to submit on Monday because I had to push everything off. So that kind of offset my schedule. But I plan to catch up on stuff this weekend. So that's the plan. And let's get right into variables. Okay, so what are variables? I want to talk about that. It's the fundamentals of what we do. And without variables, we can't store any data. We can't retrieve any data. And what I've done when I make my PowerPoint slides is I kind of highlight the stuff that I want you to remember. So again, what I do things is like, it's about storing data, and it's in temporary memory. This memory is volatile, right? And it's called RAM, random access memory, which is what it came from. So that's what it is. As soon as you turn off your computer, if you store memory in a variable, it's gone, right? So as long as there's electricity, running through your machine and you're doing stuff and your program's still active, your variable's still on. So I can talk to this thing all day long, but I think it's way more instructive to do things with Visual Studio. So let's pull up Visual Studio, please, because I think it's going to be boring you to crap if you just watch me, talk about PowerPoint. So I'm here back in Visual Studio. Hopefully you've got your Visual Studio, if you're using the machine, your personal machine, running the way it's supposed to. I've given you my vsconfig file. You did it? That's awesome. That's fantastic. And then what I want to do now is I want to make a new project. So let's do that. And last week we made a project, and it was a little bit of a console log thing, whatever. That's all we did, console write line. And so here again, I'm filtering C#, right? That's what I want to do. I want to look at a console app. That's what I'm making. All right, so just like last week, I'm going to click Next. And then here, we're going to call this ICE 2. So this is your second in-class exercise worth 6% of your final grade. And then I'm going to click Next. Here we go. And then again, please make sure that this is checked. This is like do not use top-level statements. Make sure it's checked. And then click Create. And then we should get that same empty screen that we had before. All right, here we are. So this is the same screen you had before. And let's just make this ultra big so you can see it. All right, and I'll even turn the lights down. How's that? Is that better? Hopefully you can see that. Not the greatest room. In our computer lab, our game lab upstairs, we have multiple monitors so that you can look somewhere else. Here, you have to look up here to follow along. So try your best. I am also live on YouTube right now. So that's something else. But you'd have to find me and figure out that I'm live. So you can look me up on YouTube, first name, last name. And then you might see a live link on YouTube. So if it behooves you better to watch me live and you can see it on your screen in front of you, just go to YouTube and find me there. All right. So here's this, this program. And can anyone remember what we talked about last week, which is what the heck is a namespace? Anyone? It's okay, take a chance, guys. Take a chance. Take a chance. Take a chance. Like the ABBA song, right? No?
Title.
Huh?
Title.
It's a title?
Yeah.
Okay. It's a chance. Anyone else? How about you? What do you think a namespace is?
I don't know what the C# equivalent is, but in Java it's like your package.
You got it. That's what it is. It's really a container. All right. I want you to think about these as like boxes within boxes within boxes. Okay. So here's the outer box, the outer container, which is your namespace. Inside that box, there's another little box called your class. Inside that box, there's another box in here called your function or method, right? A box within a box within a box, right? This is how it goes on the inside all the way out, right? So this is the inner box, this is the middle box, this is the outer box, right? Like a Russian doll, I guess. You got it. That's exactly what it is, right? Smaller and smaller and smaller all the way to this part right here. So why am I talking about this? Because once you get that idea that it's a box within a box, within a box, then you know that accessing stuff inside this level, you have to go through this level, and you have to go through this level and this level. So this is the outer level namespace. It's called ICE2. It's a separator. It's a way of organizing our code, right? And then there's the inner level, the class. Class, again, is like a blueprint for an object that we're going to create. And then main is the method or the function that kind of takes care of our behavior. We're doing something with main. And then inside that, you have your actual execution statement. And the statement, again, is a line of code, and it must end with a semicolon. No semicolon, no line of code. It doesn't work. The computer doesn't know how to separate one thing from the other, right? Console is a class, just like program is a class. And console has a bunch of different things we talked about last time, right? So if you press F12 when you're hovering over console, try this with me. So go on the console and press F12, right? So what you get is the actual class. This is the console class. You can see that there's a ton of stuff that the console class has, right? This is all the stuff that it has, right? So it has text reader, text writer. It has a bunch of other stuff. It has, an encoding function, encoding is your property here. It has a bunch of other properties here that it has, right? And you can see that the console class is quite large, okay? Like you can see how many lines of code this is. If I hover all the way down and go to the bottom, the console class alone is almost 1,000 lines of code, okay? So what we're doing when we use console is we are borrowing and using this code, right? And so that's, and again, I got that for people who couldn't get that, I just double clicked on console and press F12. And if you do that at any time, you'll get like the back end, what this looks like, okay? It's huge. So that's what we're doing. We're using WriteLine. WriteLine is one part of the console class. The console class is another container that contains all kinds of stuff. And here we're using that, okay? And then when we press play at the top, again, you can press play. That's one option. We talked about this last week, just as a bit of a warm-up here for you guys and a chance for some people to come in late. And we get like this hello world, right? That's what it does. It compiles and builds your program. And you can see build here. There's also another solution to compile and build. You can just build. So build, if I just do build, if I go to the build menu and go build like this, then it'll just say build succeeded. That's that, because it's a really small program. It's just going to happen instantly unless there's an error, right? And then debug, there's a bunch of ways to use debug. One of them is to use like F5, and another one is Control F5. So you can actually use the hotkeys instead. So if I used F5, it's the same as me pressing the start button, okay? And if I use Control F5, I just don't do the debugging part. Okay, so that is really what we did last week. We kind of talked about a program. We made some extra statements in there, and we also did this simple idea of a string. Let's try this together, where we said, I have a data type, string, right? And then I might have something like an identifier, which is name, right? And then we said something like, I want to initialize name. So I can initialize name with like something like, I don't know, Tom. You can put your name in there. And then we can do a console.writeLine. This is right from last week, right? Here's console writeLine. And we can say something just like name, and that'll just print out Tom. Because what it's doing is it's taking name. So here's a variable, right? And this is what the topic of today is. Variables must have a type. So type, here's the type, string, right? And name is the name of my variable. We're going to talk about that in a second. And then here I'm using the assignment operator. I'm saying that I'm assigning Tom to name. Don't think about this, name is equal to Tom, that it goes both ways. Tom is not equal to name, okay? In a mathematical formula, if you have an equal sign, it means like one side is equal to the other side. That's not what's happening here, all right? It's not equality. What it is assignment. So I'm saying Tom, I'm going to say that name now is equal to Tom. We're going to pass Tom, and we're going to store it inside of name. That's what we're doing, okay? That's a different thing, okay? And then what we're doing is once Tom is in name and we pass it in to the writeLine method, it's going to, and I got to say this again, evaluate that. It's going to take name and say, what is name? Oh, okay, name is actually, it has Tom inside of it. Let's evaluate that and turn it into a string literal, and now we're going to pass that into writeLine. So it does the evaluation, and then it passes that into writeLine. Whatever's inside of name gets passed in. Name itself doesn't get passed in. It copies whatever's in there and passes it into Tom, or into writeLine, okay? So that's this way. If I press play, now I'm going to say Tom at the top, right? We also talked last week about something called concatenation, where you have name and you go plus. When you add the plus operator and you do something like this, you know, says hello, right? If you do one of those, here's something we can do with name. Name says hello, and if I press play, you're going to see that indeed Tom says hello. That is definitely a way of doing it, okay? And what are we doing here? We're evaluating what Tom is, what name is. Name has Tom stored inside of it, right? And then we're adding, it looks like an add, but actually what's happening is this first is converting into a string, and we're taking this string over here and that string over there and smashing them together to make one long string. It evaluates this statement, this thing here, and then it converts it into one big string literal, and then it passes it into writeLine. Okay, it's not like each part is passed in. It's the whole thing is evaluated first and then passed in. Okay, and we also did this idea here where we said, well, there's a lot you can do here. You can also do other arithmetic operations. Like, for example, if I do something like 1 plus 5, that is also okay, right? And if I was to press that, you're going to see that 1 plus 5 is going to evaluate, right? There it is. And there's some stuff that it can do. So what does it do? This is kind of like what this is happening, right? It takes 1, okay, one's a numeric literal, right? It adds it to 5, comes up with an answer, and then spins it into 6. Now I have 6. Now that's the evaluated answer. Now I have a numeric literal that's 6. I see your hand. And then I take that 6 and pass that into writeLine. I don't pass 1 plus 5 into writeLine. I pass 6 into writeLine. And that's what gets outputted. Okay? Yes?
As soon as I started it up, my brackets are all red.
Brackets are all red.
Or the little separations, the little bucket we called it, it's red. And when I tried to run it, it just crashed. And like I can't close them. It just everything bugs out. So go away for a second.
Oh, here. You have see that? Yeah. That's right. Oh, I just did it.
Okay.
Yeah, you just click the back. All right, so so that's what this does. So basically what it does is it evaluates this statement in here, whatever that is. It evaluates it, and then it passes it in to write. Again, there's nothing new here, guys. This is just review from last week, okay? So we talked about that. And you're going to see this evaluation happen over and over again. Here's something else. Tom is just one value that we're passing into name. I can pass in other values in here. Like, for example, I can also say that name is equal to Rich, right? I can also say that name is equal to Bob, right? I can also say that name is equal to, we'll use a, Sarah, whatever. You see that all these things I can do, and it's okay to do that. But here's the question. What is this going to print now? Yes? Sarah, because it's the last thing that I've done. Every time I set name, that's what I'm doing. I'm setting the name variable to a value. I keep setting it to new values. So all I'm doing is, okay, first it's Tom, then I wipe it out, and I set it up to Rich, then I wipe it out, I set it up to Bob, then I wipe it out, and I set it up to Sarah. It's not like it's adding those things together. It's changing what's there, right? I'm wiping name out, and I'm assigning it something else, right? So then, just to test this, you can see that if I press play, it's going to say Sarah says hello, because that's the last thing that I did. So variables can change over time, okay? Variables aren't set forever. Unless I make them const. And that's what you might see somewhere, like up here, you might see something where it's const. So here's something if I did this. If I did a const string, const, you're going to see that everything turns red. Here's the first thing that turns red, the declaration. So this part right here is the declaration of the variable. We declare the variable. When we declare the variable, we set aside space in the computer for memory for how big that variable is, right? In this case, a string, right? And then we have assignment. Okay, so assignment happens down here, right? And sometimes assignment is also called initialization for the first time, right? So assignment's also called initialization, right? We initialize the variable for the first time, so that's what this is. Let's just do that. So the first time we change the value of a variable, as an example, it's initialization. And maybe after that it's called assignment. So then we can assign other values, right, down here, okay? But there's a problem here. Because I've made this const tells the compiler that this name can never change. It's immutable. That's what it's called, right? It's a const string, which means it can never change, right? So I have to do the assignment and the declaration in one line. I have to marry these two things together. I have to take this, right? And I have to do this, actually. Like this. That is okay. It's okay with that. But notice that because it's const, I can't assign anything else. I can't change it afterwards. I said variables changed over time unless it's a const variable. Constant is what we're saying. Constants, can never change. So question for you guys, why the heck would I want to assign something that never changes, ever? It's never going to change.
Username?
Yeah, okay, that could be the one. What else?
I was got a game title or something.
Some kind of game title. What other reason? Think about what other things I never want to change, ever, right? Something that's always going to remain constant throughout the entire game. Like, for example, I don't know, maybe for whatever reason, I want my screen resolution to never change. I want to use an old retro screen resolution of, 640 by 480, and I never want that to change, Then I can make it const. And there's going to be times where it's safer for us to make something a constant, and we never want it to change, not even by accident. So we make it const. Const helps us because it prevents us changing a variable over time by accident, okay, for whatever reason, where it can really mess up our calculations. Remember, there's two types of errors we're going to deal with, right? Some kind of syntax error where we're missing a semicolon. That's a syntax error, okay? We've tried to say something to the computer and it doesn't understand what we want. That's a syntax error, okay? And then there's a compiler error where you can see something like this, right? Where this can't be. It tells you, it says the left-hand side of the assignment must be a variable property or indexer. What have we done? We've made it const. It's a constant, a local constant. That means it cannot be reassigned. We've already assigned it. We've done the assignment already. It's done, right, for a constant. If I take const away, you can see suddenly that becomes okay because now it's not a constant. I can change it over time. That's what the difference is. And I think that's an important thing. So I did this funny thing here. I did declaration, and I also did initialization. We can say this, initialization, all on the same line, right? Declaration and initialization. And this is okay, but sometimes it's not. We might do this a lot. We might say, I want to initialize this to start off with something, a default value, whatever you want to call it, right? But there are other times we don't want this to happen, or because we're going to change it somewhere else. We want it to stay that we want to set up space for a variable, because what declaration does, if you want to put it into computer language, is we want to set aside space, memory, let's say, for this variable. That's what this does. And I'm just going to put this over 2 lines here so you can see it, right? And then initialization, what it does is assigns a value to the variable for the first time. Okay, that's what it does. That's what initialization is. Maybe I can probably put this in brackets like this, and because I really want to say this, right? Assigns value to the variable for the first time. By the way, these comments that I'm making are going to be ignored. We talked about that last week. Anything like this, 2 forward slashes are a comment for a single line comment. But we can also use multi-line comments, which I had you guys do last week when you put your name at the top of the thing, which I want you to do again. So multi-line comment is something that looks like this, right? And you put 2 stars at the top or a star at the top, and then you can put your name, something like name, Tom, right? And you can put in, the date if you really want to, in all caps. I'm using all caps today for some reason. I don't know why. September 12th, 2025, and then, the course. You can do all that kind of stuff, right? COMP1115. You can do this stuff, and this is an example of a multi-line comment, right? And there's more of this that we're going to learn about. Why this is really good, multi-line comments and single-line comments, is it communicates first to you as the developer, and then next to people who use your code later on, okay? And you might think like, oh yeah, this is super simple code, it's stupid, I'm going to remember this 5 years from now, but I guarantee you won't. If you're a coder, you're like, look back at your code and you're like, what the hell did I do here? You're going to say that to yourself, right? Unless you've got some comments in there that says, this is what this program does. And we'll do more about comments as we go. This is not important right now. I want to mention that this is what it does. And I'm putting some detail here so you understand what this is, why I can do what I've done here. Again, is I've married declaration and initialization into one statement, one line of code, and it's on line number 16. Okay, again, we use line numbers here in our editor to reference this code, okay, in this case. I also have a couple of spaces. We talked about that last week, where spaces don't matter. Like I can do this, right? I can do this. I can do this. I can do this, right? It's really stupid to do this, but I could do it, right? And I'm saying it's really stupid because it's completely unworkable, and no one does that, but you could, right? Because, and if I compile this, you can see it will compile, right? It doesn't matter, but it's dumb. Please don't do that, right? This can be done just because, again, I go back to this idea, and I'm sorry to use these tropes and stuff with you, but just because you can do a thing doesn't mean you should do a thing, okay? Just because you have a gun in your house doesn't mean you have to shoot someone. I mean, it's just, I'm sorry to tell you that, but that's how it is. And thank God we don't have guns in our houses for the most part here in Canada, right? But anyways, the point is that you can certainly do this kind of stuff, and this is okay, but I don't recommend it. I think try and stay within our conventions, because, and this is all review, by the way, from last week. Try and stick with our conventions that it looks like this. You don't want to do this either, okay? This is also okay, all right? By the way, this is not okay in some languages. Kotlin will give you errors. It will not allow this, like no spaces. So always kind of add a space in between this stuff to make it better for you. It should look like this. It should be human readable, okay? Yeah, I think so too. So that's kind of what I think you should think about. Like, just because you can do it doesn't mean you should. You can also add write lines. One thing we also talked about is write lines can also be written like this, empty, right? Because write lines have a bunch of overloads, 17 of them, by the way, right? Which means that they can take in different kinds of data, because that's how the function's been written. We haven't talked about functions yet. We will in the second half of the semester a lot more. but overloads mean the same name, different inputs. That's what it means, right? And right now you can see that there's 2 different ways of using it, and there's 3 different ways actually that I've shown you right here. We also talked about escape characters, where you can kind of use an escape character like this, a \n, right? And there's other escape characters too. Like, what if I want to print out quotation marks, right? What if I want to do that? I can't, right? Because quotation marks are the string. Well, you can do that with an escape character like this, right? So that actually will print out a quotation mark, right? Like that. You can actually print out the quotation mark, right? And otherwise you can't, because quotation marks are needed for you to indicate what the string is, the string literal. But if you want to include a quotation mark within the string literal, you have to use an escape sequence to do that, okay? So lots of little things like that that we're going to talk about. So this is really where we were last week. Any questions around this? Do you guys get this part? Yes?
So the escape sequence is just the
Backslash.
But after that, it's just another action.
Well, it's an action. So like there's a bunch of them. So if I go T for tab, that's a tab, right? And if I, now you won't notice anything, but let's just put in something like hello Tom, and then or says hello, and then we'll say hello again, right? Let's try this, right? If I just did one of those with this \T, let's try and run that, right? Then you can see that it's going to add a tab in there, right? That's what the escape \T means. And there's a bunch of those, right? And then it can space out. It can add a tab. That's almost like a tab character, which is like, I don't know, 4 spaces or whatever it is. It gets added in there, and that's something you can do too with an escape sequence. Yes?
Can you add, like I know you're adding we're adding quotation at the end.
Yeah.
Can you add a quotation like at the beginning?
Of course. So you can do that too. So if you wanted to do, you should try it.
No, like before name. 'Cause it
Right,
gives
right,
me
right.
an error.
Oh no, you can. But the thing is, see, the reason why you can't do it here is because name is a variable, right? And if you wanted to do that, you could do it like this. You could say, I'm going to add a quotation. Let's just do this, okay? So I want to do a \escape sequence like this, right? And then I can do plus name, right? Plus this, and then if I want to do, I want to put quotations around my name, I can do this to another escape sequence like this. Does that make sense? Because what I'm doing is I need to do this before name, because name is a variable that's going to evaluate on its own, and then it doesn't know what that question mark would be, right? So if I did that, then you're going to see that name now has Sarah in quotation marks around it. So funny things you can do with strings and escape sequences, okay? Try it out, guys. And if you get weird errors, you know, and if this looks weird to you, there's way more weirder stuff that we're going to do today, okay? Any other questions around stuff that we've done last week? This is kind of a review. By the way, if you look at it and you're like, this looks completely dumb, you know, whatever, I don't understand any of it, this is bad. What's going on there? Are you not logged in? Log in. All you guys. You should be online, working with me in Visual Studio. Don't watch me. Do it. Yeah.
I had a question. So
Yeah.
you did the quotation \quotation and then you had a quotation
Yeah.
but that closes off name from the rest of it so it can work properly, right?
No. So what's happening is, not exactly. Notice that there's different colors here too. I'm going to zoom in here so you can see it, all right? Take a look at the colors that the system gives you. See how this is a brown or orange, dark orange color or whatever, and then there's like this yellow color and there's another orange. This is one thing, right? This is one thing. This is a string literal. The string literal, in this case, is just a quote that's inside the string, right? We can't present a quote because we need quotes, and so to create a quote to output, we need this \/ character, which basically tells us, hey, I want you to actually give me a quote, not anything else. That's what this is. And then here, we have another literal right here, and all I'm doing is I'm adding in another quotation at the beginning of this one. And then in the middle, we're evaluating what this is, right? We're evaluating what this is. So what we're actually doing, here, let me just give you another little example, but this is a great question, because then you may understand, might solve some problems for some other people. Here, let's do this. I want you to think about what this is. What this translates into, if I was going to do it, is something that looks like this. Okay? So I'm going to say this like this. There we go. And then we're going to say plus Sarah, in this case, right? That's what this translates into. This is like, if I was going to do math, this is what kind of what it's like. Okay? Okay? So that is what it looks like after we translate it. So name evaluates to Sarah, and then that's the next line. And if I was going to take this further, then it would concatenate into a full thing. Let's do the next line. This is as if we're doing math, right? Where now it's going to be like this. So it's going to be backslash this, right? And then Sarah, right? And then it's going to be backslash this, and then says hello, and then like this. So this is where we started. This is what it evaluates this first, and then it creates this. That's what it's doing, one thing at a time. And these all these three lines are identical. It's the identical output. Like if I was going to show you these three lines, and if I was going to print them out, then it should show me the exact same thing over and over again. Oh, sorry, I made a mistake in the last one because I added a space in here. Here, it's actually like this. Sorry. There we go. Same thing, right? And why is this all the same? Because this translates into this, and then this translates into this. It evaluates. That's what evaluation does. It takes whatever I've given it, changes it into something that it understands, and puts it into this format. Questions for this one? Yes?
Why would we not just write it how you did it at the end instead of...
We could, but then we wouldn't have a variable, would we? Right? This is hard-coded. We don't want to hard-code anything, right? Then what if I wanted to write Tom in there? I'd have to write that statement again, right? So that's what the variables are for. Variables allow us to interpose, whatever we have in there. We can change it out and make it whatever we want. For example, we can say something like, if you're logging into a system, you can say, welcome, Tom, right? But then it might be something else. Welcome, Michael. Welcome, Sarah. Welcome, Bob, right? The same thing is going to be used, same text, but for different people. No, it's like we're actually injecting the name in there. That's what we're doing, yeah.
Bunch of errors. I don't know what I got wrong with it.
Okay. Well, hold off. We're going to do more stuff, and then we'll go through your errors at the break, okay? So let's continue. So now that we've got this, again, this is all review from last week. We've talked about evaluation. I want to wipe this all out and start fresh. So let's do that again. This is just from last week, so don't worry. Please log into your Visual Studio. Are you in? You don't know how to log in? It's your first initial last name, and then there's you have to have your network password, whatever that is. It's usually the same password that you log into Georgian with. Okay? So your first initial last name, I think, is what it is, right? Is that what you guys are using to log in?
I use student number.
Oh, there you go. Student number with what? Student number at Georgian. Whatever it is, and then that's what you need. So use that, and then that's your username, and then your password is your password. Can someone help them out? All right. All right. So now today, so that was review, and what we want to do is for today, we want to talk about variables. So now that you know, just as a warm up, we just did that, and one thing that we want to talk about here is I've translated some parts of the things that I'm doing for you in this PowerPoint, okay? But I'm not going to read the PowerPoint. This is for you to read. This is for you. I've given you references. So if you want to read up about variables and more details, here they are, right? But one thing that we want to talk about is this idea that when we put a variable, when we do assignment for a variable, we put a value inside of it. This idea of a name and a type, and then we put a value, those really are the three things we need for a variable. Some kind of name for the variable, some kind of type, and what you're going to put in it. That's what a variable is, right? In a nutshell, okay? So, when we talk about it, we talked about declaration and assignment. Declaration, again, we're reserving a spot in memory, and assignment is we're putting something in there, right? So one thing we can have is a good example of a variable might be, in our case, the player's health. We we're game people. We're not just making, applications for banks, okay, or something else, right? Like that would be very boring. Or we're not accountants, we're game developers. So I want to think about what we would use variables for things like players' health, or in this case for our in-class exercise 2, we're going to be using creating stats for our character. That's what we're going to be doing, okay? So here's an example of what we already know. A string, we have a username, and then some kind of console write. Now console write is different than console write line in that it doesn't add an entry. So let's try this. Let's say if I did something like console write, let's do this together, console write, and then I say something like, please enter your name. Let's try this, right? Space, okay? That's something we can do, right? And you're going to notice if I just press play here, if I just do a console write and press play, there's no spaces between this and this. There's literally no space. It's like hugging these two things, right? This part, of course, in the inside of your console is just gobbledygook. It's nothing. It's just telling you, hey, yeah, everything worked. Yes. What was your question?
Yeah, I apologize if my debug is a little slow.
Okay.
But it still works.
Good. All right. Don't worry about it. So, console write is like console write line, but you know what write line does? If I do the same thing, if I do a console write line, what it does, console write line automatically includes that \n, goes to the next line. That's what it does. It makes your statement and goes to the next line. That's what console write line does. Console write doesn't go to the next line. It stays there. It just prints it out and doesn't go to the next line at all. So it's like console write is like console write line without the \n. That's what it is, okay? So this is really neat. And now I want to get input. We've been doing output last week. Let's do some input. In order for me to do input, I need to have a variable to accept the input, all right? So let's make a string, and we'll do it up here. I always kind of declare my variables up here. So I'll use a string, and we'll call this, like it says in the example, username, right? Here's my username string. So here I'm declaring it, okay? So I'm declaring, the username variable. Okay, that's what I'm doing. I'm declaring it. Declaring it means putting memory aside. I'm going to ask you this question next week. Putting memory aside for a string. All I'm doing is putting memory aside. Okay, I haven't done anything. I haven't assigned anything. Username right now is empty. It doesn't have anything inside of it. Okay? And then it's just called username. You can call this whatever you want, by the way. I'm just calling it username. You can call it name, something else, right? The next part is I want to do a console read line. Okay, here's a console read line, and a console read line, if you hover over it, look what it says. Console read line, it says reads the next line of characters from the standard input system, that's the console, right? And it says returns the next line of characters from the input system, or null if no more lines are available. It returns a string. What about write? Write doesn't return anything. It returns void. See that right here? It says void. It returns void. Void means nothing. Void means it doesn't return anything, right? But this read line does return something. It returns a string. It actually takes whatever you've read and it returns something. So when this evaluates by itself, it evaluates with whatever the user typed. Okay, so that means that I can do assignment. I can do something like this. Username is equal to this. Why? Because readline will take a string and from whatever the user enters and pass it into username. That's what it's going to do. Okay, console readline. Now it's giving me some little marks here, and let's see what it says. It says, converting non-null literal or possible null value to a non-nullable type. So it's warning me. This is the little warning that says, hey, what if you don't get anything? What if the user doesn't enter anything at all? What's going to happen? You're listening for a string, and you might get nothing. That's what it's telling you, okay? And if you're okay with that, you can ignore the little warning. These are warnings. Warnings are in another color, right? It's not red. If it's red, it's an error. I'm going to go back to like Star Trek and Spock. An error, okay? It's actually not how you say it, but he also says sensors, right? If you're a Star